Okay, so our next one is writing the equation for the altitude. So on here, they want us to write the equation for the altitude of the side AB. So I need you to go ahead and copy the steps for the altitude. Here, we're going to have to find the slope of the given side that they tell us to write the equation to, because the altitude, by definition, which we're going to apply geometrically on the coordinate plane, it must be perpendicular to a side, and it goes through the opposite vertex. That opposite vertex part is a key component. Most people miss that when they're doing the equation. So I'm going to let you copy the steps. I'm going to get this triangle graphed. You need to get it graphed as well. We're using, and I think I forgot my coordinates are not up here, but we're using the same coordinates from before. So A is -4, 1, B is 2, 7, and C is 4, -3. I'm going to go ahead and get that graphed. You can pause the video if you need to, if you've already done that, and move on. Alright, so once you got your triangle graphed, the first thing is we're going to find the slope of AB, because this is the equation we're trying to draw. This is the side that we're drawing the altitude to. So we need to find the equation, or the slope, sorry, of AB. And I'm just going to count my rise over run. And I can see this is just going up 1 over 1. So the slope of AB is 1. And then to do the altitude, we have to find the perpendicular slope. So that's just the opposite reciprocal. So that's going to be a -1. Now, we are going to start at C because we're doing the altitude to this side. So we have to look at the opposite side to understand which vertex we're starting at to graph the line. So opposite vertex is C. We're going to have a slope of 1. So that means up 1 to the left 1. Left 1, and we're going to do that slope until we hit the side AD. That gives us which line we are constructing, which is perpendicular. And I went a little bit too far. I apologize. Just that a little bit. There we go. All right. Now, we started at C, use the slope of the perpendicular, graph the line. We would repeat this for all 3 sides. But first we want to write this equation. So after we do the perpendicular slope, it's to start at the opposite vertex, use that slope to plot additional points. Then we're going to go to plotting the slope, the point slope form. Now when we do that, we got to remember that we are using the perpendicular slope, which was the -1, and we're using the vertex of the triangle, which is 4, -3. That was our C that we started from, okay? Now, so I'm just going to put this in point slope form. We have y plus 3 equals a -1 parentheses x minus 4. If I need to put it to slope intercept form, we would just distribute. So we would have y plus 3 -x plus 4. Subtract the 3, and we would end up with, I need to make some room. Excuse me. But y equals -x plus 1. Now, they want us to find the location of the orthocenter. That is the intersection of the 3 altitudes. And to do that, I need to go ahead and draw them to see, do I have an exact point, or am I going to have to use some system of equations to solve to find the x and the y coordinate. So I'm now going to do side BC, okay? What I do is, first step is to find the slope of side BC. And I'm going to count my rise over run. And if I look, I'm going up 10 to the left 2, so -2. 10 over 2 can be reduced to a -5. All right. And then we got to do the perpendicular slope to this side. So perpendicular would be 1/5. And now I'm going to use that slope to graph the altitude. Now, since I'm doing the side BC, I've got to go to the vertex opposite that. And that is my A, which I erased by accident. Apologize. And we're going to start at A, and we're going to use the slope of 1/5. So I'm going to go up 1 to the right 5. And I want to do that until I hit the side BC or intersect it. And I can see there's my line as such. I'm just going to draw my box, which that's all I need to really indicate for an altitude, is to show that we have a right angle. It's perpendicular. And I want to do the same thing, but I can kind of see already. Do we see that how our green line and our blue line does not intersect at an exact point? So that tells me that I'm going to have to use a system to solve it. But let me just go ahead and practice and show you how to find or how to draw the altitude. Get my pen. Sorry. For side AC. So first thing we do, step 1 is find the slope of AC. Use your rise over run. That comes out to be, if you count, a -1/2. And then we're going to do the perpendicular slope. That's going to be a +2. So if I'm going to do the altitude to AC, that means now I'm starting at which vertex? B. That's exactly right. So we are now going to do a slope of 2. So that would be up 2 to the right 1. Well, that's not getting me to AC if I go up 2 to the right 1. So I'm going to go down 2 to the left 1. And I want to repeat that at those additional points until I intersect and I can see that altitude right there. But then again, remember, I only needed two altitudes to intersect to find the orthocenter. So because, again, this is not an exact point, and my lines are a little off, I apologize about that, we're going to have to use a system of equations to solve it. And that means I'm going to have to I need another equation here. I need the equation for one of the other altitudes. Well, I can find the equation of the altitude using our point and the perpendicular slope. But we have to use one of the vertex. So let's use the vertex dealing with the B, the line we just got finished drawing. So our B was 2, 7. The perpendicular slope for the altitude dealing with that was 2. So the perpendicular slope was 2. And then we're just going to use point slope form. And put it in slope intercept form so we can use substitution again, or I'm going to do elimination just to practice that as well. So let's go ahead and distribute. We have y minus 7 equals 2x minus 4. We're going to add the 7, and then we get y equals 2x plus 3. All right, so that was the equation for the altitude for the side BC, our red altitude. Now, let's put this in standard form. I need to basically move our x's over, okay? So let's do that, and I'm going to bring it down right here. So if I move the x over on this one, we would get x plus y equals 1. And we move the x to the other side to get it as well in standard form. We would have negative 2x plus y equals 3. Now, right now, the x's and y's are lined up, but I don't have opposite terms. I have a 1x and a negative 2x, and then a positive y and a positive y. So I want to multiply one of them by a negative 1 to get rid of, so we can eliminate our y. So I'm going to go ahead and just do the top by negative 1, and I'm going to bring it down when I do that. So this is going to give me a negative x, negative y equals negative 1. And now I can do elimination to solve for x and to get our one of the coordinates, our x coordinate for our orthocenter. So when I do that, the y's will cancel out. You're going to have a negative 3x equals a positive 2. And then we're going to divide by negative 3. All right, I need to extend the page. And then we get x equals negative 2/3. And I ran out of room, or not ran out of room, but overlapped. So let me fix that. So that is our x-coordinate for our orthocenter, negative 2/3. And if I want to find the y-coordinate, I can plug it in to any one of these equations that I had for the altitude. I can do the red one or I can do the green one. I'm going to do the green one because that's real simple. But I want us to do the green one so we can remember to watch our signs. So on the green one, we have y equals a negative x plus 1. So when I plug it in, y equals a negative, parentheses, negative 2/3 is what the x is, plus 1. That actually becomes a positive. So I'm going to have a positive 2/3 plus 1. Well, 1 whole will have to be 3/3, which would give me a positive 5/3. 2/3. And there is our coordinates for our orthocenter. We can use system of elimination to get to our x and y coordinate. All right, there you go. Thank you.